this video is going to show us how to take some like requirements for a function and then write an equation to match it. Okay, so we're going to keep kind of those things in mind about the degrees and how to get horizontal and vertical asymptotes. Okay, so here I want to write a rational function that has a horizontal asymptote of 2. So if it's not 0, remember this means the degrees are the same and the leading coefficients are 2 and 1 or like 4 and 2, okay, to get 2. Vertical asymptotes, those mean I have those values are in my denominator and I don't have any holes, so they can't cancel with anything. Okay, so the most basic thing, there's more than one that would accomplish this. So let's see, we need a leading coefficient of 2 and 1. The denominator, I need x plus 3 and x minus 3. Okay, now you might want to say stop here, but remember I need the degrees to be the same. This degree is 2, right? X squared, if I were to multiply that out, I'd get an x squared. So I need x squared in the top. Now, you could write anything. I'm just going to write x squared, okay? You could do x plus 1, x plus 2, lots of different things. This is just one option. But now I made sure my degrees are the same so that I get this. No common factors, and I'm just going to put a y equals in front of it. Okay, here, y equals 1. This is the same situation. I need the degrees to be equal and my leading coefficients to be 1. This time I have a vertical asymptote at 2 and a hole. Okay, so let's see. If I have a hole, I know I have x minus 3 in the top and x minus 3 in the bottom, right? So that's for the hole. Now I have a vertical asymptote at x equals 2, so x minus 2 has to be in the numerator, but again, I need the degrees to be the same. So I need to add another factor up here. You can make it whatever you want. I'm just gonna make it be x. I'm just gonna move this a hair. Because now I have degree of 2 on both the numerator and the denominator. Coefficients are 1s, okay? And then again, just put a y equals or an f of x equals in front of it. Okay, here I want my horizontal asymptote to be 0. So remember, this is degree on bottom is bigger. Okay? No holes. All right, so I need the bottom to be larger. Okay, so if I want a horizontal or I want a vertical asymptote at x equals 0, there's that. No holes, so it could honestly just be as simple as that. This technically is a degree of 0. This is degree of 1. So as long as it's bigger on the bottom, then I have that horizontal asymptote of 0. I don't have any holes. We're good. Okay, no horizontal asymptotes, no vertical asymptotes. Okay, so nothing can make our denominator equal 0. The other thing I need is I need it to be bigger on top. Okay, so this is, and we have a few holes. We have a hole at x equals 1 and x equals 2. All right, so let's start with the holes maybe. So x minus 1 and x minus 2 are both in the numerator and the denominator. Okay, but in order for them to not have any vertical asymptotes and no horizontal asymptotes, I need the degree to be bigger on top. So I need another factor here. Can be anything. I could do x plus 3. Okay. Now, the other part of this is we could leave it just like this because now my degree equals 3 and here my degree equals 2. So it's bigger on top. These are not going to be vertical asymptotes because they're going to be holes. So this could be my equation. All right, horizontal asymptote at 1, no vertical asymptotes, and no holes. Okay, So this time I don't have anything that cancels. I need the same degree on the top and bottom, and I need a horizontal asymptote at 1. Okay, so no vertical asymptotes means we need something that I can't get to equal 0. So this is an example where I have things like x squared plus 1. I'm just going to make this guy up. So because I cannot put anything for x to make it equal 0, so that would be something that is no horizontal asymptote and also no holes. And that's just one example. You could do plus anything, x squared plus anything. Okay, now I need a degree of 2 because I want a horizontal asymptote 1, so I could just do x squared because I have 1 and 1, and so that's going to give me that horizontal asymptote. These can't cancel because I have addition involved there. So this would be a sample equation. Okay, something else, we've done a little bit of this. We found the zeros. That's also called the x-intercept. Okay, so I'm going to put that in there, x-intercept. We did that in the last video. We can also find the y-intercept. This is by plugging in 0 for x and then simplifying. Okay, so let's start with the x-intercept. X-intercept, we set the numerator equal to 0. Sorry, that should be minus. So x equals 3 and negative 4. So my x-intercepts are at 3, 0 and negative 4, 0. Okay, y-intercept. This is where I plug in 0. So I'm finding what is f of 0. So I'm putting 0 in for every single x. And simplifying. So here I'm going to get negative 3 times 4 over negative 1. So negative 12 over negative 1 is 12. So the y-intercept is at 0, 12. When we put in 0 for x, we got 12. And I think that's it for this video, you guys. All right, thanks for watching.